Good evening, girls. Welcome for day 3 session. And today's session is also aptitude and reasoning skills. Hope you enjoyed the session on aptitude and reasoning yesterday. So today is also the same kind of topics we're going to cover. So I would like request the students to make note of the shortcuts what our guest speaker is going to share with you. I take immense pleasure in welcoming our guest speaker for today, Ms. Shabana ma'am. And over to you, Shabana ma'am, for the aptitude and reasoning session.
Uh, so thanks everyone. So a very great evening for each and everyone here in the live now. So I believe the yesterday session went on really well. Just give me a second. Okay, so I believe yesterday's session went on well. We found out many short new techniques to find out the squares and cubes of all the two-digit numbers. We split the two-digit numbers into three different types to find the squares and four different types to find the cubes, and so. So in this particular session, maybe for the next 1 hour or 1 hour and 15 minutes, we are going to see problems based on, that is, your applications based on your squares and cubes. Okay, so I have taken a couple of problems, not much as such. So I've just taken a very few problems which has a lot of techniques involved in it. So before going to the problems, I would like to start with the puzzle. Okay, so before going to the problems as such, we are going to start with the puzzle. So let me just give you a short introduction about this particular session. So as I told you, like we have 5 different problems with 5 different applications. So I've written the 4 problems here on the board. So you need not worry on that. We'll come back to this. But before going for the problems, I would like to take you through the puzzle. Okay, so I hope you're all ready, and you can let me know for any comments or feedback, answers, or whatever it is. So we are going to talk about a puzzle now. Now this puzzle is all about 3 people. Okay, so this puzzle is all about 3 people. Again, the people here in the puzzle are A, B, and C. Hope the board is visible now. So the people involved in the puzzle are A, B, and C. Okay, imagine this, these 3 people are into they are into farming side. They are into, maybe their profession is into farming. So the problem or the puzzle is all about the tractors. Okay, the puzzle is all about tractors. I hope what tractors mean is, tractor is a vehicle that has been used to plow all your cultivation part. So what happens is that they transact tractors between all these 3 people. That is, A transact between B and C, B transact between A and C transact between A and B. So listen to the puzzle very carefully, open up your ears and do answer. Now let's say it's the first turn and the turn belongs to A. Now what happens? A lent is, lent is just giving. So A lent tractors to B and C as many tractors as they already had. That is, in case if B had 2 tractors and C had 3 tractors, A must have given another 2 tractors to B, and A must have given another 3 tractors to C. So that's what the statement means. So this is just for example, 2 and 3 are not the numbers, but this is just for an example. So the first turn is A's. So A lent tractors to B and C as many tractors as they already had. That is, A lent as many tractors to B as they already have, as B already have, and as many tractors to C as it already had. Okay, so the first transaction is over. Now comes the second transaction, which belongs to B. So now B lends tractors to A and C in the same way. That is, B lent as many tractors to A as it already had, and as many tractors to C as it already had. I hope the question is clear now. Okay, I repeat from the beginning. So this, we are going to start this particular session with a puzzle. The puzzle is all about 3 people, A, B, and C. So they lend tractors to each other. The first turn belongs to A. So A lent tractors to B and C. Okay, as many tractors as they already have. That is, the numbers may not be the same. It is not necessary that B and C has to have the same numbers. May not be the same. So A lent as many tractors to B as it already had, and A as many tractors to C as it already had. And similarly, B lent tractors to A and C in the same way. That is, B lent as many tractors as A already have to A again, and as many tractors to C as it already have again. Okay, so the first two transactions are over. Now comes the third transaction, and of course, it belongs to C. So now what happens is again C lent as many tractors to A and B as many as already they have. Now remember one point that you have to be very careful in all the three transactions is that nobody is going to give the same numbers to no one. Okay, so it is all different particular and it may not be the same. Maybe or may not be. It is not necessary that it either has to be same or not the same as well. So C lent tractors to A and B as many as they already have. So all the three transactions are over. So the first turn of A is done, the second turn of B is done, the third turn of C is also done. So after all the transactions, each of them, that is all A, B, and C, each of them had 24 tractors each. Okay, now let me just shorten it and write, right? So now it is the turn of A, B, and C. So the first turn is A's, the second turn is B's, the third turn is C's. Okay, so after all the transactions, each of them had 24 tractors each. Each of A, B, and C had 24 tractors. Now, my question, I hope you must have got my question. My question is very clear. How many tractors does A, B, and C had before they start their transaction? Okay, so before they start lending to each other, because before A start, how many tractors does each of A, B, and C have? Okay, so you can start giving out your answers and you can let me know even if you have any clarifications on it. I repeat the question again. Maybe the late joiners or people who have some issues can listen to it again. We are going to start the session with the puzzle. So the puzzle is all about A, B, and C. There are three farmers A, B, and C, and the transaction of tractors is what this puzzle all about. The first turn is A's. So A lent tractors to B and C as many tractors as they already had, and B lent tractors to A and C, again as many tractors as they already had, and C lent tractors to A and B as many tractors as they already had. So after all the transactions, each of them had 24 tractors. So how many tractors were there in the beginning of the transaction? That is before they start to transact, before they start to lend, how many tractors does each of them have? Again, remember, it is not necessary. Since the last number is 24, it's the same. It is not necessary that it has to be 24 again in the beginning. It may not be the same number. So you can think and post your answers. And you can let me know if you have. Yes, Vedika, you have something to say?
Ma'am, it's not necessary that all of them have the same number of tractors, right?
Exactly, exactly. So the question is very clear. Now, at the end of the transaction, the number of tractors with each of them is same. With each of A, B, and C are same. But it is not necessary that it should be the same number in the beginning of the transaction as well.
Okay, there are guesses from the student side saying eight tractors
Please.
each.
8 tractors. Okay. Now let me come back to your question. See, this is actually a very good platform to start. Now, if you say that they had 8 tractors each, so if they had 8 tractors each in the beginning, imagine. So A gives tractors to B and C. So if B had 8 tractors, A must have given another 8 tractors to B, and A must have given another 8 tractors to C. So which means that A must have had number of tractors more than C. It has already given 8 and 8, 16 tractors. It has already lent. Okay, so if A is going to give 16 tractors to B and C, definitely A must be having more than 8, at least more than 16 in number. A must have had more than 16 tractors with him. Only then it could have given 8 tractors to B and it could have given another 8 tractors to C. So that's why I said the number of tractors in the initial stage may not be the same. You got it? I guess the students got it. People, you remember, see, A is going to give tractors to B and C in the beginning. So, which ultimately means that, which is a high clue that A is going to have a higher number of tractors than B and C. So, it may not be the same number of tractors that each of them had. I hope you got it. So, 8 is not the answer. You can try with different other numbers. You can let me know with different other numbers. We can just cross verify and see. Any other answers? Any other answers? Vedika, you have any other answers with you?
Okay, ma'am, is it possible that initially A has 24 and B has 12 and C has 12?
Okay, can you repeat the number, Vedika? A has 24 and B has 12 and C has 12, isn't it? So
12,
let's just
yes.
start with this number. Yeah, so now if it is going to be, this number in the beginning, so A had 24 tractors and B had 12 tractors and C had 12 tractors. So as in I told you, A starts the transaction. So A gives as many tractors to B and C as they already have. So which means that A could have given another 12 tractors to B and another 12 tractors to C. Okay, so the number of tractors with B is 24, with C is 24, and with A is 0. Is it right? So A has already given 12 tractors to B and 12 tractors to C. That is 24 tractors it has already lent. So A initially had only 24, which ultimately it has given to everyone. So A has 24 tractors at the end of A's transaction. Now it is B's turn. Okay, if A has 0 tractors, of course B could have given another only 0 tractors, because I told you the question in such a way that B gives as many tractors to A and C as many as they already have. So which means that since A has 0 tractors, B must have given another 0 tractors to A. So C has 24 tractors, so B must have given another 24 tractors to C. So A ultimately has 0 tractor, B ultimately has 0 tractors at the end of B's transaction. So at the end of B's transaction, this will be the number. So 48. Now it is going to be C's turn. Okay, so C is going to give again 0 tractors to B and 0 tractors to C. So ultimately, C gives no tractors to A and B, so C has the same number of tractors to them. So the number should be 40. So at the end, it must not be 24, 24, 24, and it should have been 0, 0, and 48. If 24, 12, and 12 is your initial numbers. I hope you got it. Okay, if 24, 12, and 12 is your initial numbers, okay, this must have been the case at the end. That is, A had 0 tractors, B had 0 tractors, and C had 48 tractors. So this must have been the case at the end rather than 24, 24, and 24. But I told you, the answer, the end of all the transaction leads to 24 tractors each, which means that 24, 12, and 12 is not the answer. I hope the explanation is clear for everyone. Okay, so if it is going to be 24, 12, and 12, you will ultimately, according to the question, you draft everything, analyze, you get 0, 0, and 48 at the end of all the transactions, which is no way is possible. Because I told you at the end of the transactions, each of them had 24 tractors. So it leads that 24, 12, and 12 is the wrong answer. You can suggest or you can give me any other answers.
How about 24, 8 and 8, ma'am?
24, 8, and 8. 1 second. All right. So if it is 24, 8, and 8. Okay, if it is 24, 8, and 8. So it is first A's turn. So A must have given another 8 tractors to B and 8 tractors to C. So now B has 16 tractors, C has 16 tractors, 8 and 8 is 16. So A has lent 16 tractors to B and C. So 24 minus 16 is what you're supposed to find, which means that 24 minus 16 gives you 8. So A has 8 tractors at the end of A's transaction. So this is the number of tractors at the end of A's transaction. Now let's say, so it is B's transaction. B is going to give for A and C. Okay, so B must have given 8 tractors to A and 16 tractors to C. Right, so 8 and 16 is 24. B cannot give 24 tractors to A and C because B only had 16 tractors. So with 16 tractors, it cannot lend 24 tractors. So again, there's a contradiction, which means that 24, 8 and 8 is not the answer. See, good that you are thinking, okay? This is small mistake, okay? I mean, it's not a mistake, it's the way you assume a problem to be. Instead of guessing the numbers like yesterday, I hope you all remember the puzzle we solved yesterday with Mayor Brogan, right? He had 3 different articles to buy, and he went into the hat shop to buy a $10 hat, and then a suit shop to buy a $10 suit, and then a pair of shoes for $10 again, by doubling it. So all these he did. So at the end of the day, he went out with $0, right? So we calculated from the end, and this is what we are going to do today also. So ultimately, problems like this has solutions. Your major clue, your biggest clue is this. Each of them had 24 tractors at the end of the session. Can I give you the answer, or do you want somebody? I mean, any other numbers to try? If you have any other numbers to try, maybe we can go ahead with that, or I'll give you the answers.
Yeah, I guess we can go ahead with the answer, ma'am. We are curious to know how to solve it.
Okay, to solve it, right? All right, now listen. See, I'm going to start from the bottom. Okay, I'm not going to start from the top. This is my major clue, so I'll start with top. So, since each of them had 24 tractors at the end, and it is going to be C's turn at the end. So, the last turn is C's. So, of course, C has lent the tractors to A and B, as many as they already have. So I'm just going to see the entire puzzle from the other side of it. Okay. So after giving, C gives tractors to B and A. After lending tractors to B and A, B had 24 tractors and C had 24 tractors. So which means that before lending, okay, A must have had 12 tractors and B must have had 12 tractors. You got it? So only in that case, C must have given another 12 tractors. C must have given another 12 tractors to A and 12 more tractors to B. Only then the number is 24 here. So which means that C has given 12 tractors to A and 12 tractors to B. So it has ultimately lent 12 plus 12, 24 tractors to A and B. So after giving 24 tractors to A and B, C still have 24 tractors. So which means that before giving, C must have had 48 tractors. I repeat. Okay. So I just come from this. I take you all through this. Now C has 48 tractors with him before transaction. Okay. Before lending, C has 48 tractors. So A has 12 tractors and B has 12 tractors. So C gives 12 tractors to A, 12 tractors to B. So 12 and 12 is 24, 12 and 12 is 24. So already 12, 12, 24 tractors is being given to A and B. So which means that 48 minus 24, C still have 24 tractors. So with this number, the last, the final number of tractors with each of them satisfies. Okay, so with 12, 12 and 48, the final number of tractors with all A, B and C satisfies. So I take this in the same way. I again see the problem from the other side of it. So C's transaction is over. Now it's done. Now before C, it was the B who has lent tractors. So B has lent tractors to whom? B has lent tractors to A and C. So B has lent tractors to A, that is in such a way that A had how many ever tractors, the same number B gives to A. So after giving, okay, so forget about this number, forget about this 12 which has been added, it is for our understanding. So B has given to A and C. After giving, A has 12 tractors. So before giving, A must have had 6 tractors. And after giving, C has 48 tractors. So before giving, it must have had 24 tractors. Now B has given 6 plus 24, which is 30 tractors to A and C. So after giving 30 tractors to A and C, B still have 12 tractors. So 30 plus 12, which is 42, must have been the number with B before it transacts, before it starts a transaction. Now let's come from this side and see. Okay, so in the beginning, before giving, before B's turn, the number of tractors with A, B, and C are 6, 42, and 24. So it is B's turn to give A and C. So B gives another 6 tractors to A and 24 tractors to C. So which means that this has become 12, this has become 48. Now 6 plus 24 is 30. So 30 tractors B has given. So minus 30 should give you 12. Okay, I hope it is clear again, right? Now again, the logic is still right with B's transaction. Now again, let's go back to the other side of the problem and solve in the same way to get the initial number of tractors. So we'll erase all this, right? Now let's again begin from the, from A. So now it's A's turn to give to B and C. So A has given as many tractors to B and C, as many as they already have. So after giving, B has 42. So before giving, B must have had 21 tractors, just the half of it. Okay, after giving it was 24. So C must have had just the half of it, which is 12. Right. So 21 plus 12 is 33. So A has lent 33 tractors to B and C, and A still have 6 tractors with it. So 33 plus 6 is 39, and 39 will be the number of tractors before A starts its transaction. Okay, so let's again come from the from the beginning. So it was A's turn. B, A is lending tractors to B and C, as many as they already have. So A has lent 21 tractors and 12 tractors to B and C respectively. Okay, so which means that it is 42 and it is 12. So this is minus 21 plus 12 is 33. So minus 33 is 6. Now it is B's turn. So it has given 6 tractors to A and 24 tractors to C. So 6 plus 24 is 30. So it has given 30 tractors. Now this is 12 minus 30 is 12 plus is 48. Okay, now it is C's turn. So C has lent 12 tractors to A and 12 tractors to C. So 12 plus 12 is 24. So minus 24 is 24 again. Okay, so ultimately A, B and C has 24 tractors each. Is it clear? Is it clear for everyone? Okay, let me tell you, like, this is the what to say, like, it's a very beautiful problem defined in such a way that it talks well about your analytical power, like how you think from the other side of a problem is the best example for the concept is best example for this. I hope the problem is clear for everyone.
Yes, ma'am. It's crystal clear, ma'am.
Hmm? All right, good. So we'll move on for today's session. Okay, so we'll move on with today's session. Right, so as I told you in the beginning, I had taken 5 different unique problems which talks about the application of your squares and cubes, and I've written the problems here on one side of the board. So we are going to take each and every problem to the other part of it, solve, and then erase the problem. So out of 5, it's only the 4 problems which is on the board. Okay, so the 5th problem is a greatest suspense for you all. So which I'll let you know at the end of all these 4 problems. So the first one is this, S square plus 85, plus 85 square is equal to 165 square minus 89 square minus 2863. Remember, okay, I am definitely not going to solve each and every number here. So that's the greatest, the time saving part for me. I will, even though I know to solve 85 square, I know to solve 165 square, I know to solve 89 square. I have lot of shortcuts to find the squares of 2-digit, 3-digit, I am definitely not going to apply anything here just because of one reason, because of my choices. Now, if you could look at the choices, I have choice with units number as 9, units number as 0, units number as 3, and units number as 6. That is, I have choices with different unique units number. So, which ultimately tells me that I am not going to solve each and every number here on the board. Okay, so I'll just start with the shortcut. In case if I have my units number as same, in case if I say I have 80, I mean say 96, 86, or 89, 99, 79, and 49, or something like that. If my units number are just going to be the same, of course I don't have any other choice. I have to work out with all the numbers, with using all my shortcuts, using all my tricks to find the answer. But in this case, I am not going to do that because my choices have different unique units number, right? So what I'm going to do is I'll take s square, okay, simply s square plus 85 square. So of course 85 square ends with 5. I know 5 square, this is my units number, so 5 square is going to end with 5. Let me write down the problem here on the board so it will be clear for you all. So I write it s square plus 85 square is equal to 165 square minus 89 square minus 2862. Okay, so this is my problem here. Now I'm going to take s square. So 85 square, I know 85 square is going to have 5 in my units place. So I just write 5 here. So here again 165 square will definitely have 5 in my units place. So this is 5 here. Okay. So minus 9 square. So 89 square has 9 in my units place. So 9 square is 1. So I mean sorry 81. So ultimately I'm going to have 1 in my units place. Okay, so minus, the number is very direct, so I take the last number of it, which is 3. Simple. Okay, so this is s square plus 5 is equal to 5 minus 1 is 4. 4 minus 3 is again 1. So I'm going to have a number which has 1 in my units place. So s square will be, I'll take the 5 to the other side, so 1 minus 5. See here, it's very, very important. It is not that 1 minus 5, so minus 4. No, it's not that way. Remember, this is a number which definitely has some number in the previous digits. That is, this is my ones digit. So I'm going to definitely have tens digit, hundreds, thousand, 10,000. May it be beyond that also. So I'm going to have a number here. I do not know what number it is. Imagine there is some number in your units place. So you have all the numbers here and there's some number in your units place and again some numbers here. So you're going to subtract this. So what do we generally do? We will borrow. Okay, so once if you borrow, this becomes 11. So 11 minus 5 is 6. So it is not 1 minus 5 minus 4. No, please don't do that. So it is going to be 1. So if you are going to subtract, you will have some number in your tens place. So you will naturally borrow and this becomes 11. So 11 minus 5 is 6. So I'm going to have some number which has 6 in my units place. Okay, I repeat till this again, right? So with this problem, I am not going to solve the problem entirely, even though I know the shortcuts, short tricks to find the squares and squares of 2-digit and 3-digit number. I am not going to solve it because of my choices. The choices have unique units digit. All my units digit are unique. I have 8, 9 here, 3, 6 and 0. Okay, so since my choices have unique units number, I'm just going to play with the units digit. So I'll take a square. I know 5 square ends in 5, 165 square ends in 5, 9 square ends in 1, and 3, the number is as such 3. So I'll take the number as it is. So 5 minus 1 is 4, 4 minus 3 is 1. So this I'm taking this number to the other side of it. Imagine it is not, it is definitely not going to be 1 minus 5 minus 4. No, you should not do that. Instead, remember, this is a 4-digit or 5-digit number. We do not know that it's a 4-digit or 5-digit number, and again the subtrahend is also a 4-digit or 5-digit number. So usually while subtracting, we tend to borrow. So that's the initial thing. So we tend to borrow. So it is not 1. Either it becomes 11. So 11 minus 5 is 6. So yes square is some number which ends in 6. So ultimately, I came to a decision that s square is some number which ends in 6. Okay, so what are all the square or square roots that has units number as 6? So yesterday we saw that it is 1 square, 1, 2 square, 2, sorry, 2 square, 2, 3 square, sorry, 2 square, I'm sorry, 2 square, 4. Okay, 3 square is 9, 4 square as 60. So 4 square as 60. Okay, so I have 6 in my units place. 5 square, 25, 6 square is 36. So again, I have one more number which has 6 in my units place. So of course 7 square, 8 square doesn't have 6 in my units place. So I'm not going to write that. So it can either be a number that is s square can be a number which has 4 or 6 in its units place. Okay, so s square, okay, is a number which has either 4 or 6 in its units place. That is, yes is a number which has 4 or 6 in its units place. So I'm going to see what are the numbers that has 4 or 6 in its units place. So 89, it's not the case. 693, not the case. 90, no way possible. So 96 should be my answer. So I came to a conclusion that the value of yes is 96. Okay, so I did not do any calculations. I am not going to waste my energy. I'm not going to waste my space indeed, right? So I am just going to work on a shortcut way to find the answer, and my answer is 96. Okay, I hope it's clear. So let's move on to the next problem. I hope it's clear. Vedika, you have anything else to say?
No, ma'am. No, ma'am. It's clear and easy to understand.
Sorry, Vedika.
It's clear and easily understandable, ma'am.
Okay, Vedika, fine. Thank you so much. Okay, so let's move on to the next problem. So the next problem, I'll write the problem clearly here on the board. The problem is this. Okay, it is 38 square plus 63 square plus 87 square, and you have to find the value. Okay, 38 square, 63 square, 87 square, you have to find the value. Now, let's apply the same strategy and see. 8 square, 4, 3 square, 9, 7 square. See, I'm taking only the unit number. Okay, 8 square, 4, 3 square, 9, 7 square also ends in 9. So 9 and 9 is 18, 18 and 4 is 22. So ultimately my last digit should be 2. Okay, now let me just check the choices. I have two possibilities. So I have 2 here and I have 2 here again. Okay, so which means that I cannot apply this and find the answer. But how does it differ? So it differs with my tens digit. Even though my ones digit is same, the number differs with my tens digit. So it is fair enough if I could know what my tens digit is. So I can easily find my answer. So now let's work out with that. So I'm going to do this 38 square plus 963 square plus 87 square. So we know the shortcuts to find the squares. So 3 square 09, 8 square 64, 3 8 24, 24 I double it 48 I add end 0. Okay, now remember I am not going to add everything. That's again at least I can save 3-4 seconds. Okay, so I just take 4, 12, 13, 14. So 44. I would not add the rest part of it. Now 63 square again. 6 square 36. 3 square 0963 is 18. Double it 36. So 360. Now my number is 69. I end with this. So 87 square. 8 square 64. 7 square 49. 7 8 is 56. I double it. It becomes 112. So 1120. Now 9 and 6. I end with this again. Right, so I am going to add only 69, 69 and 44 to get the last two digit to find my answer. So this is 212 here. So 12 and 13 plus 4 is 17. I'm sorry. 12, okay, 16, 17. No, just check if I've done anything wrong here. So 6 and 8, 12, 13, 14, right? 36, 0963 is 18 twice, 360, right? 7 8 56, 56, 112. 14. Okay, so you could add and see 7 and 10, 17. Okay, must be wrong with the choices. The choice must have been anything else. Okay, you ultimately have, let me just check with the problem again. Sorry, it's a mistake. So this is 2 and this becomes 8. So it is 82. So this should be your answer, right? So definitely by this you can save a couple of seconds. So I am not going to add everything, take all the numbers and see its exact value. I did this because my last digit is 2 in either cases. Both of my option A and B carries 2 in my last digit. So which means that I have to take the other digit. My tens digit varies. So I'm going to calculate, check up my tens digit to know the answer. So only the 2 digit that I'm going to take and find the answer ultimately. And 82 is the last 2 digit of these two numbers. So I'll go with this as my answer choice. Okay. So in such cases, suppose if I have, 8 also here, I would go with the hundreds place. Again, take the hundreds place alone and check. See, if definitely if you're going to have different numbers, having ones, tens, hundreds, thousands place same, ultimately it's your bad luck. So you have to work out the entire problem and check. But otherwise, if you have problems like this, if you have choices like this with tens digits same or hundreds digits same, at least few seconds you can save by checking up only the last 3 digits or last 2 digits according to the choices. Okay. I hope it's clear. So let's move on to the third problem. So the third problem is this. 16 into 5 power 4, okay, equal to, let me erase all this, equal to what? Okay, 16 into 5 power 4. See, if you are calculating like this, 5 square, 5 power 4, 5 into 5, 25. 25 into 5 is 125. Again, 125 into 5 is 625. So 625 into 16, if you wanted to find out, I am very sorry to say that you are wasting a lot of time. Okay, so we are not going to solve by this. So the moment you see 5, okay, the moment you see 5, immediately you have to think that 5 is nothing else but 10 divided by 2. Because anything with 0, either you multiply or you divide with 0, it's going to be the easiest part. So I will write 16 into 5 power 4 as 16 into 10 by 2 power 4. Okay, 16 is nothing, 5 is nothing else but 10 by 2 power 4. So after this, it's very easy. 16 into 10 power 4 divided by 2 power 4. And you all know 2 power 4 is nothing else but 16. 1, 2, 2 is 4, 4, 2 is 8, 8, 2 is 16. So you cancel these two to give the answer as 10 power 4. Okay, so if you are going to take 5 power 4, 625 multiply by 16, ultimately it's your waste of time. So please don't do that. The moment you see 5 anywhere multiplied with any other number or even in division, just take, it's not imagination. You just take that 5 is nothing else but 10 by 2, which will definitely save a lot of time. Okay. Similarly, you can find 216 into 5 power 8. So if it is 216 into 5 power 8, okay, if it is going to be 216 into 5 power 8, I'm going to take 10 by 2 power 8. So 2 power 8 is nothing else but 16. So I just remove this. So, even for your better understanding, let me not do this. 216 10 by 2. So you take 216 into 10 power 8 divided by 2 power 8. So 2 power 8 is 216. We'll just cross verify. 2 2 is 4, 4 2 is 8, 8 2 is 16, 2 is 32. 32 and 2 is 64. 64 and 2 is 128. 128 and 2 is 260. 128 into 2. Okay, so you can directly say 10 power 8 will be your answer. Now let's move on to the next one. I hope the last question is visible for you all. Okay, so June has, I'm telling you that June has 25 working days. Okay, June has 25 working days. Then July has July has 34 working days. Okay, July has 34 working days. So how many working days does April have? Okay, I repeat the problem. So if in case June has 25 working days, July has 34 working days, how many working days does April have? Now, if you could just look at this problem, it is no way related to the number of days, number of months. I mean, definitely it is not possible. See, logically, the problem cannot go in this way because a month cannot have more than 30 working days. But the question is framed in such a way that it is illogical to see the problem, which means that you must be having some logic related to the letters. You must be having some logic related to the letters. Now, let's say June has 25. So, June is some way related to 25. July is the other way related to 34. So, in what way are these two related to 25 and 34 is what we are supposed to find. Now, let us just take, we'll write all A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Okay, I'm going to give numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. Okay, fine. So now it's just that you see like June, J stands for 10. I'm going to write the numbers here. U stands for 21. Okay, N stands for 14. Okay, N stands for 14. Then it is E stands for 5. So you add everything 10, 21, 14 and 5 and just see how is it related to 25. Similarly for July, let me write down the number. So J is for 10. U is for U. Where is U? U is for 21. Then L is for 12. Okay, then Y is for 25. Okay, so we can just add these numbers and say, so this is 31, 30 or 21 and 14. Okay, so this is 31 plus 19. So 10 and 5, 50. So I'm getting 50 here, right? So this is 50 and this is 31 plus 12 plus 25. So this is ultimately 7, 8 and 6. So 68. I'm getting 68. Right. So 50 is related to 25 in such a way that you divide by 2, you get 25. Similarly, 68, you divide by 2, you get 34. So let's work out in that way and see. So April, A stands for 1, P stands for 60, R stands for 18, then I stands for 9. Okay, then L stands for 12. Okay, so now let me add everything. 1 and 9 is 10. Okay, 18 and 12 is 30. So 40, 56. 56 divided by 2 will be 28 and that is my option C. Okay, I have option C as 28 and that is going to be my answer. Okay, so see the easiest way is like the moment you see July has 34 working days, which is not at all logic. You immediately have to think that it is some way related to some part of coding. Okay, I hope these questions were clear. So as I told you, the next question.
Hello.
Yes, Vedika.
Yes, ma'am. It was actually really very easily understandable. And but is there any
Okay.
other alternative way to do this? Because writing down the alphabets and then numbering them, that's again going to be time consuming.
That's right. That's right. But you practice a lot of problems, you immediately can take the value of letters as it is. It comes only by practice.
Okay, okay, ma'am.
And if you have a couple of problems related with the alphabets and so, maybe you can use those alphabets written for the other problems as well.
Okay, sure, ma'am.
Hmm? All right. Good. Fine. So let's move on to the next one. So the fifth question is this. Okay, let me write down the fifth question. I want you all to just think, how is it possible to calculate? Just think on the problem and try to calculate. Okay, now the problem is this. It's a triple eight to the power 999 into 999 to the power triple eight. Okay, plus what is number can we take? We can take 444 to the power 555 into 555 to the power 444. Right? I hope you can see the numbers here. It is 888 to the power 999 into 999 to the power 888 plus 444 to the power 555 plus into 555 to the power 444. Maybe the number looks very large. You must be wondering like are these literally possible to find in the given span of time? Of course, it takes some time, but people who's going to give this problem or the examination, I mean according to the examination point of view, they will definitely not ask you to find the entire answer. They don't want you to evaluate and give the answer because a calculator can does it, of course in a short span of time. But without the calculators, using some part of the logic, they want you to find only the last digit of this evaluated part. Okay, we are supposed to find, I don't want the entire answer, of course. We are supposed to find only the last digit of this entire part. Okay, so you calculate everything, only the last digit is what we're supposed to find. So how can we find the last digit for this? Maybe if it is just single number, you can just take, but it doesn't mean that 8 power 9, 9 power 8, 4 power 5, 5 power 4. Definitely, please don't take it in that way. It's no way possible. Let us take one example. If I say 2 to the power 4, okay, and say 2 to the power 14. Okay, so 2 to the power 4 and 2 to the power 14 will not have the same answer. Not necessarily it should be the same answer. So that's no way possible. Okay, maybe with the numbers it can sync sometimes, but not for all the numbers, right? So it is not that way. So remember, you have to find only the last digit of it. So finding the last digit of this particular problem is very very simple. It's just a cakewalk. It's very simple. Okay, with one single strategy which I'm going to explain to you now. So please listen to the strategy very carefully. There are a lot of methods. You have cycle numbers and everything, but I will never believe in cycle numbers because that's again time consuming. You have to remember the number, you have to calculate its cycle value, and then take the problem ahead. So instead of that, it is just a single a single a very shortest strategy to find the answer for this problem. So the moment I see the problem like this, asking me to calculate only the last digit, okay. So one point that I comes into my mind is, for whatever number that I had to find, I take the number as x, y, z to the power n. I take the number as x, y, z to the power n, where I am going to focus only on z and I am not bothered about x and y. It can be any number. See, it is not necessary that it has to be triple eight. I can even still have 8 and 8 here. And it is not necessary that it should be only triple and I can still have 9 and 9 here. It can be any number. So the one thing that I am focused is only Z and N. Okay, all I'm bothered is only Z and N. That is my last digit and the number in the power. Okay, now let's take this example. I'm going to take this number. So I'm going to compare this. Let us take 888 to the power 99. So in this case, sorry, 999. So in this case, 8 is my Z and 999 is my N. Okay, Z is 8 and 999 is N. Alright, now let's say the moment I find this, the next step that I do is I divide N by 4. Is the number in the power by 4. So once you divide any number by 4, you have a possibility of this is something that comes under your remainder theorem. So any number you divide by 4, you get a possibility of getting remainders as 0, remainder as 1, remainder as 2, or remainder as 3. So these are the three possibilities. Now if you get a remainder 0, you look out for Z, that is the basis last number. If your Z is even, it will be 6. If your Z is odd except 5, okay, except 5, your last number will be 1. This is a universal record. You just have to remember, that's it. You divide the number in the power by 4. If you get a remainder 0, it means that you have to look out for Z. If your Z is even, the last number is 6. If your Z is odd except 5, the last number is 1. If your remainder is 1, the last digit is Z. If your remainder is 2, the last digit is Z square. If your remainder is 3, the last digit is Z cube. Okay, I repeat. Now you take this number for instance, all your focus is only Z and N. So the number in the power you divide by 4, you have a possibility of getting remainder 0, 1, 2 and 3. If your remainder is 0, you look out for Z. You look out for Z is odd or even. So if it is even, it is 6. If it is odd except 5, okay, it is 1. If your remainder is 1, your last number is Z. If your remainder is 2, it is Z square. If your remainder is 3, it's Z cube. Done. Okay, now let's just check with this number. Let's take this number and see. Now, before again dividing by n, you have to understand one. Okay, the divisibility rule for 4. Okay, how do you generally find out? Just by looking at the number, how do you say a number is divisible by 4? By taking the last two digits. So the divisibility by 4 says that the last two digits should either be 0, 0 or any number which is divisible by 4. So suppose if you have a number like this, so 100, it has 0, 0 at the end, last two numbers are 0, 0, it is divisible by 4. If you have 800, last two numbers 0, 0, divisible by 4. 300, last two numbers 0, 0, divisible by 4, right? Or if it is not 0, 0, it should be any other number which is a multiple of 4. Suppose 332. 32, you just look out for 32. 32 is divisible by 4, then the whole number is divisible by 4. It can be 3333 also. You just look out only for the last two digits. The last two digits is divisible by 4, then the entire number is divisible by 4, right? So it is the same way. Now, since because your divisibility rule for 4 is you look out only for the last two digits having either 0, 0 or any two numbers which is divisible by 4, you apply the same thing here. So it is just enough if you divide the last two numbers by 4 and see the remainder. See, the quotient may vary. Okay, you divide 999 by 4 and 99 by 4. The quotient may vary, but the remainder will be the same. That's what the divisibility says. So number when you divide 999 by 4, you get the same remainder when you divide 99 by 4. So I mean to say that it's fair enough that if you divide only the last two digit by 4 and check the remainder. So I do not take 999, I only take 99. 99 divided by 4. So 100 is divisible by 4. So 99 will gives you a remainder. 99 will gives you a remainder 3, of course. So because 96 and then you have 94. So you remove 96 from this, your remainder will be 3. So if your remainder is 3, you look out for Z cube. So Z cube, 8 cube. We know 8 cube is 512. So this number will have the last digit as 2. Okay, so this number will have the last digit as 2. So if you are going to check in the same way for all the other numbers, okay, if you are going to check for all the other numbers, let's apply the same here and see. So it is 99. You divide 99 by 4. So 99 divided by 4 will give you a remainder 3. So since it is remainder 3, it is Z cube. Z is 8. So 8 cube is 512. I have 2 in my units place. I multiply. Now in this case, so I take 88, 88 divided by 4, my remainder is 0. So if my remainder is 0, I look out for is it is odd or even. So is it is odd, which is 9. So odd and none, we take is it, I mean the last digit as 1. So this is 1 here. Okay, 2 into 1. Now plus I have the operator, I just put the operator just the same. So 55 divided by 4, my remainder. So my remainder will be 52, I guess will be the last number. So 1 and 2. So after 52, it is only 56. So 55 will leave a remainder 3. I reduce 52 from 55 and my remainder will be 3. So if my remainder is 3, it is Z cube. So 4 cube is again 64. So this is 4. So I put it in the bracket. Now into 44 divided by 4. So 44 divided by 4, of course, it leaves the remainder 0. If my remainder is 0, I look out for Z. But here comes the problem. So if it is Z is odd except 5. Z is of course odd, but it is 5. Okay. So what will be the number? You cannot take that if it is except 5, then you have to go for 6. No, it is not that way. Now let's take 5 power 1 is 5. So 5 square is 25. 5 power 3 is 125. 5 power 4 is 625. Okay, so if you could observe, you have 5 in all the units place. So 5 power any number gives you 5 in your units place. So that is why I need not go for, if I have 5 in the place of Z, I would not touch this table at all. I would never see what is it is. I would never see what n is. I would not divide it by 4. I would do nothing. I would just blankly say that if I have z in my basis last number, my last digit is just 5. I do not go for any other, any other process. So 5 power any number gives you 5 in your units place. So I'll just take 5 here, right? So 2 into 1 is 2 plus 4 into 5 is 0. So 2 plus 0 is 2. So ultimately the last number for this is 2. So the last number for this is, I hope it's clear. You can let me know if you have any queries.
No, ma'am, it's clear, ma'am.
It's clear. Okay, so let's try with some other number and then come back for any other, clarifications. Now let me take this number. Let's say, let us have 220, or let it be like this: 2, 3, 4 to the power 5, 6, 7 into 8, 9, 10 to the power 11, 12, again plus, so 13, 14 to the power 15, 16 into 17, 18 to the power 19, 20. Okay, so let's just calculate this. I don't have any numbers coming into my mind. I am just writing down the numbers as it is. Okay, so here you apply the same thing. You have 4 here. So this is my Z and this is my N. I mean, I take only 67. So 67 divided by 4. Okay, so 67 divided by 4 leaves a remainder 3, because 64 is a least number. So it leaves the remainder 3. Since it is 3, it is Z cube. So 4 cube is 64 into 0. Now coming back to this, I said 5 power any number gives you, gives you 5 in your units place, right? So that's why I term 5 as one of the magical number. Okay, because of this reason, I term 5 as one of your magical number. So I have 3 other number like this. Okay, so you can guess as what 3 other numbers are. So any number in the place of Z, okay, will give you the same number at the end of your evaluation. That is, in the place of Z, if you have 5, 5 power any number gives you 5 in your unit space. Similarly, there are 3 other numbers. Power any number gives you the same number in the unit space. Any guesses about the numbers?
No, ma'am.
Okay, so the numbers are, 0. 0 power, any number gives you 0 in your units place. Say 100, you take even square, will have 0 in your units place. Similarly, 1 power, any number gives you 1 in your units place. So I'll take this 0, 1, 5, and there's one more number which is 6. 6 power, any number gives you 6 in your units place. So 6 power, any number gives you 6 again in your units place. So the magical numbers are 0, 1, 5, 6. The reason for separating out the magical numbers is that if you have 0 or 1 or 5 or 6 in your units place, that is in the place of visit, you need not go for any calculation. You need not divide by 4, you need not see the last digit, you need not see the remainder, nothing. You can just blankly, with your eyes closed, blindfolded, you can say that 0 or 1 or 5 or 6 respectively will be your answer and just walk out. If it is going to be any other number other than this, of course, you have to do the calculation and just see. And it is not that difficult, so you can just see and tell the answer. So since I have 0 here, it is going to be 0. So plus, okay, let me erase all this. So plus, then so I'll take this. Now 4, 50, 16. 16 of course is divided by, it is divisible by 4. It leaves a remainder 0. So since it is the remainder is 0, I look out for is it is odd or even. This is even. So if it is even, the table says the last number is 6. And here 20 again divisible by 4. So if it is divisible by 4, okay. So if it is divisible by 4, so again you look out for is it is odd or even? Is it is even again. So the last number is 6. So this is 0 into anything is 0 plus 6. Your answer will be 6. So ultimately this calculation will give you the answer as 6 in your units place. Okay, so just by looking at the problem in few seconds, in just seconds, you can give the answer. So that's the highest, part of this concept. I hope it's clear. Now I have a few questions. Okay, let me raise the question, and you can let me know if you have any answers. Right now, let's say I am just giving you some number with some powers, which in turn, if you just try it on the calculator, it would definitely say either a syntax error or a math error. So you're not going to get the answer for it. So in those cases, how could you definitely, or how could I definitely say that this will definitely have 0 in the units place? Okay, at least for this it's convincing because you have 0, you can say it's 0. In these cases, say in these cases, how could I definitely say that I have only 6 in my units place, I have 6 in my units place. Now how is it possible? Now let's just cross verify. Let me take what is 2 power 8. Can you find what is 2 power 8 again? 2 power 8. So 2 power 8 is 2 twos 4, 4 twos 8 again, 16, 32, 64, 128 and 256. So 2 power 8 is 256. Okay, since you have 2 power 8 as 256, okay, my question is what will be, forget about 256 as of now. Just don't think about 256. Only just say 2 power 8. Now my question is what will be the units digit? What will be the units digit of 2 power 8? As you all know the answers, as you all know the Vedika, you were about to say something.
No, ma'am, not at all.
Okay, fine. Let me continue. So 2 power, as we know, 2 power 8 is 256. My question is, what will be the units number of 2 power 8? Okay, so what will be the units number of 2 power 8? Now we all know the answer is 6. So as we all know the answer is 6, let's just verify with that the table. Now 2 power 8 is here. Okay, as you know that this is your n. 8 is your n and 2 is your z. So I am going to divide n by 4. So 8 divided by 4 will leave a remainder 0. So I divide n by 4, I got the remainder as 0. So n is 8, I divided by 4, my remainder is 0. So if my remainder is 0, I look out for z. If it is odd or even. So if it is even, I would say that the number is 6. If it is odd, I would say the number is 1. Okay, so z is of course 2, which is even. So ultimately, my last digit will be 6. Isn't it goes well with the same thing? Okay, is it convincing? Right? So we just had 6 in the units place without even calculating. Now let me take 2 power 9. So 2 power 9 is 256, the double of it, which is 512. 512, right? So I'm going to cross verify again with the same concept. If 2 power 9, I'm going to find the value, the last digit of 2 power 9. So I divide 9 by 4. So 9 divided by 4, my remainder is 1. If my remainder is 1, the last digit is Z. Z is 2, so I'm having 2. Okay, so convincing, right? So not here, but the arrow goes here. Okay, so similarly 2 power 10. So 2 power 10, I know it is 1024. My last number is just 4. Let me just cross verify with the same concept. 2 power 10. Okay, so 10 divided by 4. 10 divided by 4, my remainder is 2. If my remainder is 2, it is Z square. Z is 2. So Z square, 2 square will be 4. Yes, it's the same way. So let me take the arrow to this side, right? So this is how this, I mean, after observing all these values, after only this, the concept has been derived, the table has been drafted. So it's very easy. You just have to look out for z, that is your basis last number and the value of n. You divide n by 4, you have a possibility of getting remainder 0, 1, 2 and 3. If your remainder is 0, the last number you have to see if z is odd or even. If it is even, the last number will be 6 universally. If it is 1, it will be, I mean, sorry, if it is odd except 5, it will be 1. If your remainder is, 1, the last number is z. If your remainder is 2, it will be z square. If your remainder is 3, it will be z2. So that's how it goes. Okay. Now, I have one more question. What is the, okay, why is that I should divide it by 4 and not by any other number? What is the reason that I should divide? See, the power, okay, the power, that is the value of n, I'm dividing it by 4. Why is it 4 and not by any other number? Have you ever thought about it? What is the, the speciality of 4 here? Of course, 4 is a very, very special number, even though some people may say, that that's not, that's not a good number, or, they have so many stories with 4, but still, 4 is a very, very unique number as far as aptitude is concerned, because we must have not noticed that when you take the numbers in the order, okay, when you just multiply the numbers in the order, the units number is just repeated for every 4 numbers. Now let's take any number as such. Let me go with 7. So 7 power 1, so 7 power 1 is 7. 7 square is 49. 7 power 3 is 343, and 7 power 4. To find 7 power 4, I'm going to take 49 square. So 49 square is 4 square, 16, 9 square is 81. Okay, 4 into 9 is 36. 36, you just double it, it becomes 72. So 720. So 1, 0, okay, 4 and 2. So 2401 is your answer. 2401. Okay, so I know 7 square, right? 7 power 1 is 7, 7 square is 49, 7 power 3 is 343, 7 power 4 is 249. Now, if you could observe it very carefully, see, to take 7 square, I'm going to multiply this by 7, it is 49. Good. Now, to take 7 cube, I multiply 49 with 7. Now, I don't bother about 4 here. So, 9 sevens is 63. Okay, 9 sevens is 63. That is, my units number is just the same. Here again, I don't take 34 into account. I just multiply this by 7. So, 3 sevens is 21. Is my units number just the same? Right? So, 7 sevens 49, 7 and 63. My units number again 21. My units number So ultimately, 7 power 5, I need not go with the answer at all. I only have to multiply this by 7 and see the last digit. To find the last digit, I need not multiply the entire thing. I can just say that my last digit is 7. Last digit is 7. Now 7 power 6, okay, my last digit will just be 9. 7 power 7 will have my last digit as 3. And 7 power 4 will have my, sorry, 7 power 8 will have my last digit as 1. So 79317931. Similarly, if you wanted to take 7 power 9, 7 power 10, 7 power 11, 7 power 12. Okay, it is just going to repeat the same way. It has 7 in my last digit. It has 3 in my, sorry, 9 in my last digit. It has 3 in my last digit and it has 1 in my last digit. So 7931 will be the pattern to follow. Okay, so this we must not have observed. It is not only for 7, it is for all the other numbers. For every number, the number in the units place for every 4 numbers repeats. When you start multiplying it, the number in the units place for every 4 numbers will definitely repeat. So that is why we take 4 as the unicity and divide it, find the remainder. Okay, how many how many yens are there is not we are bothered about. We only bothered about the remainder. According to the remainder, you draft a strategy and find the answer. Okay, so all the questions have been posted and all the I think all your doubts should have been cleared. So you can go for any questions if you have, or any problems if you wanted to solve.
It was all clear, ma'am. Maybe
Good.
if possible, can you give a small gist of the sum again?
Yeah, sure. Which problem, ma? I mean,
Uh,
for all the entire problems, is it?
yes, ma'am.
Okay, right, good. So, see, this particular session we started with a puzzle. Okay, the puzzle was about the lending tractors with three people, A, B, and C. So we started with the puzzle. Later on, we had five different problems. Most of it the applications of your all your numbers. So there were problems which involved, I mean, with different choices with different units numbers, choices with the same units number, and different strategies to calculate and shortcuts method. So we also had a problem from coding and decoding. We had a problem like June had some number of working days, July had some number of working days, which is quite irrelevant. So since the number is quite irrelevant, we took the problem to the other side of it. We solved it with the coding pattern, and then we had a strategy to find the number in the units place. Okay, so to end with, to end with, I would like to give you, I would like to, display a couple of problems, and if you could just solve and give me the answers, that would be real. That would be a real part of it. So now let's say 99 to the power 11 into 11 to the power 99, or let's take addition in between 22. So you can try this, and also, so I have noted down two different problems. Okay, I've noted down two different problems. So you can start solving and give the answers. That is 99 to the power 11 into 11 to the power 99 plus 22 to the power 88 into 88 to the power 22. Okay, so the next problem is this. There is some number where the number is this and your value of n is this. So to evaluate, I want you all to evaluate and find the last digit of it. Even in this case, just the last digit of it. Okay, I'll give you a couple of minutes. Just try if you could solve this. Okay, so let me solve this and give the answers. So 11 again divided by 4 leaves remainder 3 because 8 is your multiple of 4. So you remove 8 from that, you have 3. So since your remainder is 3, you look out for Z cube. So 9 cube is 729, so I take only 9. 1 is my magical number, so I just take 1. Okay, plus 22 cube. Again, 88 divided by 4 will leave a remainder 0. So if my remainder is 0, I look out for Z. Z is of course even. So the last number in this case is 6 into 22 again. So 22 divided by 4, my remainder is 2. So 2 in sense it is 8 square. That is Z square. So 8 square which is 64. So this is 4. Okay, so now I add, this becomes 9 plus 6 fours is 24, 4. So 9 plus 4 will leave remainder, will leave the last number as 3. So 3 is my last digit. Okay, so 3 is my last digit in this case. So if you practice well, it would not take much time. Not even this time, you can quickly manipulate and give the answers. So here in this case, a, b, 4 to the power 4n plus 1. All you need is this number and this number. So we, as I told you in the beginning, we are not bothered about the rest of the other numbers. So only 4 and this is what we require, right? So I know my Z is 4 and my N is 4N plus 1. So the first step that you have to do is you have to divide this by 4NC. So remember 4n plus 1 divided by 4. So of course 4n is a factor of 4. So 4n is a factor of 4 which means there are a multiple of 4 which means that, okay, so this would leave a remainder 0. So since this leaves a remainder 0, ultimately when you divide 4n plus 1 by 4, you have a remainder 1. Okay, so you when you divide 4n plus 1 by 4, you have a remainder 1. Now, if you say, ma'am, this is not at all, we are not able to understand this at all. Something like factor, multiple, so and so, no, it's not getting into mind. Simple, very simple. Don't worry. Okay, now I tell you a very, very easy method. You have 4n plus 1, and you have to divide this by 4 and see. Take the value of n as 1. So, if you take n as 1, n is 1, so 1 into 4 is 4. 4 plus 1 is 5. 5 divided by 4, your remainder is 1. Again, take the value of n as, see here is that I took n as 1, I got remainder as 1. Now, if you take n as 2, okay, take n as 2. So, 2 fours is 8, 8 plus 1 is 9, 9 divided by 4, your remainder is 1. Your remainder is 1. Now, take n as 3, 3 fours is 16, 16 divided by 4, your remainder is 1 again. So your remainder is 1. Take n as 4, 16 plus 1, 17. Again divide by 4, your remainder will be 1. So whatever the value of n is, your remainder will always be 1. Okay, so that's what it actually means. So 4n plus 1, when you divide by 4, 4 is a factor of 4n. So 4n is a multiple of 4, so that becomes 0. So remainder will be 1. So if you have remainder 1, of course, the last number is just Z, which is 4. So this will have 4 in your units place. Okay, so you have actually speaking, you have lot of problems like this. Numbers is a very, very huge concept. Okay, where most of the competitive exams and campus placements will play with numbers. Let's say you have a number like this, 52,900. Okay, into 34,300. Okay, find the number of factors for it. Find the number of factors for it. See, these all, that is your factors, multiples. We have been doing this right from, see, I mean, I have a daughter who's just class 5. So even she has all these factors and multiples. So right from class 5, class 4, till almost your, class 10, we have been doing these factors and multiples. But only pathetic part is that for some point of time, we forgot all that. Right. So finding out the factors and now see, maybe in your school days, you must have found out the factors of all these numbers. Maybe for smaller numbers, not this big numbers. Say, let's say you would be given a number like this 56. You must be given a number like this 48. Find the factors for 56 and 48, which is a very, very easy part, not time consuming. But now Okay, you the problems are disguised in a different way. Just the disguise is the strategy. I mean the challenge here. Okay, so you have numbers like this 52,900 into 34,300, where you can't do anything with the calculator to find the number of factors. So this all has a specific pattern. Okay, maybe if time permits, we'll meet for another session. So that time we will discuss all this. I mean, the ways to find the number of factors and so. So I ultimately finally end this session by saying that you have lot of different new techniques. Okay, lot of strategies, especially with numbers, because all the other topics are pretty easy. The moment you practice, it just comes to your hand. But that practice will ultimately start only with the numbers. So numbers is a very, very important concept. Try to focus more on it to find the largest number of strategies. Okay, you can let me know if you have any questions.
No, ma'am. I guess all are everyone are clear with the concepts, ma'am, and it's easy to
Okay,
understand as well.
that's great. Thank you.
Hello. Thanks a lot, Shabana ma'am. That was a wonderful session and a lot of positive feedbacks I could see in the chat box. It was an excellent session and things. And thanks a lot for your patience in handling this aptitude session for our students. I hope our students would have got some insights what does aptitude is all about and a lot of topics and aptitude. So they may even wonder so that it is not that easy to crack the aptitude even in interview process unless or until we practice it regularly. So that is my humble request, my dear students. Please just don't ignore by just learning aptitude today. Every day do practice. There are a lot of aptitude books available in our college library. Please make use of it and practice it. And because practice makes a man perfect, unless or until you practice it, it will be difficult for you girls to crack the interview process when it comes for the campus drives, as Shabana ma'am has rightly said. So thanks a lot, Shabana ma'am, and thank you very much, students. We have posted the feedback link for day 3 in the YouTube chat box. So please do fill in the feedback and send it us before 7 p.m. today. So tomorrow's topic would be interview skills. So I request all the students to log in at least by 3:45 p.m. That is 15 minutes before the session, so that it will be easy for us to track from 4 p.m. So thanks a lot, placement team. Thank you very much, Tamarai, for coordinating technically. Thanks a lot for all. Thank you.